Okay, picture this. A piece of software that literally cannot lie. And I don't mean it chooses not to lie. I mean it's fundamentally incapable of misrepresenting what it did. It's a wild idea, right? Well, it's the whole point behind this incredible engineering project called the C99 Canon. It's a system built from the ground up to produce what it calls a non-negotiable testimony of everything it does. So, how on earth do you even build something like that? Let's get into it. All right, here's how we're going to break this down. First, we'll touch on why you'd even need software that never lies. Then, we'll get into the heart of it, the Bedrock engine, and the super strict rules it lives by, the 7 pillars of law. From there, we'll see the exact process it uses to create its testimony with something called the witness contract, and how it proves it's the real deal with the locksmith's signature. And of course, we'll wrap up with why any of this really matters. So, what's the big problem we're trying to solve here? Well, look, if you've ever had to debug a complex system, you know the feeling. It's pure pain. Data gets messed up, logs just disappear, or what you do have is totally incomplete. And when things go sideways, you're stuck playing detective, trying to figure out what really happened from a bunch of clues that might be lying to you. And that right there leads to the huge central question that drove the C99 Canon project, which also goes by the name Fractal Joule Engine. The goal isn't to just ask the software to be honest. No way. It's about engineering a system where honesty is the only option. So, is it actually possible? Can you design code so rigidly that it's literally forced to tell the truth, the whole truth, and nothing about the truth about what it did? And the answer this project gives is a loud, clear yes. It is absolutely possible. But we're not talking about just another app or a simple program here. The C99 Canon is something much more fundamental. They call it a bedrock engine. Think of it like pouring a perfect, solid concrete foundation before you even think about building the house. It's the base layer you build on top of to create systems that can prove they're telling the truth. So let's really unpack what that means. When they say deterministic legality, they mean its behavior is totally predictable. It follows the rules every single time with no exceptions. And non-negotiable testimony? That means its logs, they're not just logs. They are the absolute, unimpeachable source of truth. The whole point of this engine is to create a perfect, mathematically provable record of what it has done. Now, this next idea, fail-closed witness, is probably one of the most important concepts here. See, most software is designed to keep going no matter what, right? It'll try to recover, maybe it'll drop some data, or write a messy error log, but it keeps chugging along. This engine, it does the exact opposite. If for any reason it can't create a perfect 100% complete record of what it's doing, it just stops, cold. The core philosophy is simple but powerful. It is far better to say nothing than to risk saying something that isn't the complete truth. Okay, so how in the world do you build something that disciplined? Well, you start by giving it a constitution, an ironclad one. The entire C99 Canon is built on what the project calls the 7 pillars of law. And these aren't just guidelines. They are strict, non-negotiable rules that control every single thing about how the code is designed and how it behaves. And every single one of these pillars is there for one reason, to stamp out any possibility of ambiguity. For portability, it means no fancy modern stuff. It has to run on ancient systems, so you know it's built to last. For time, it uses one simple clock source, period, no confusion. Strictness is a huge one, and we'll circle back to that in a sec. The rules for formatting in JSON make sure data can't be misread. Then there's completeness. The code has zero to-dos or dead ends. And finally, memory is managed with obsessive care to prevent any kind of corruption. It's a whole legal system for writing code. And this right here perfectly captures that strictness pillar. These are the actual commands sent to the compiler. And that last one, W error, that's the real kicker. What it does is tell the compiler, hey, if you see anything that looks even a little bit suspicious, not an error, just a warning, I want you to treat it like a 5-alarm fire. Stop everything. The build fails. There is zero tolerance for, it's probably fine. All right, so we've got this super strict legal foundation for the code. Makes sense. But how does the system actually, do anything? How does it produce that testimony we've been talking about? Well, that's all governed by a very rigid procedure they call the witness contract. And it really all comes down to 2 simple but powerful ideas, the tick and the door. Let's talk about the door. You can think of it as the only way into the system. It's like a building with one single, heavily guarded front door and no other windows or secret passages. It's a bottleneck on purpose. Every single thing the system does has to go through this one gatekeeper.
and that gatekeeper performs a full-on top-to-bottom inspection every time.
And before the system does even one tiny bit of work, what it calls a tick, it has to follow this 5-step contract. It never deviates. First, it announces exactly what it's about to do. Then it verifies its own source code to make sure nothing has been tampered with. After that, it validates all the incoming data. Only then, once all those checks pass, does it execute that one single tick of work. And the very, very last thing it does is commit the ledger file, the official testimony of what just went down. This brings us to a really cool idea, the ledger first principle. Here's a good way to think about it. That tick file, the JSON ledger, that's the official record. It's the stone tablet. It's the testimony. Everything else, all those other files, they're just caches. They're like scribbled notes on a whiteboard. If you accidentally erase the whiteboard, who cares? You can just look at the stone tablet and rewrite the notes perfectly. The ledger is the one and only source of truth. Okay, but there's still one last, really important piece to this whole trust puzzle. We've established that the system creates a perfect record of what it does. But how do we know that the system doing the recording is the right one? How can we be sure that the software itself hasn't been secretly modified? We need to close that loop. And that's where the locksmith's signature comes in. The secret is this one file, manifest.sha256.txt. You can think of it as a detailed, notarized inventory of every single file in the codebase. And next to each file's name is its SHA256 hash, which is just a fancy term for a unique digital fingerprint. If you change even one comma, one single character in any of those files, that fingerprint changes completely. The seal is broken and everyone knows something's up. And here's what that actually looks like inside. It's pretty straightforward, right? You've got the file name on one side, like makefile or tick.c, and on the other, you have this super long string of letters and numbers. That string is its unique identity. It's its fingerprint. So here's how all these pieces lock together to create this amazing, unbroken chain of trust. You can run a command to verify the code against the manifest anytime. But here's the kicker. The door, that single entry point we talked about, automatically does this check before every single run. And to close the loop completely, the digital fingerprint of the manifest file itself gets embedded in every single testimony file. So you have mathematical proof that the record was created by this exact verified version of the code. It's brilliant. Okay, let's zoom out for a second. We've been deep in the technical details, but what's the big picture here? Why go through all this incredible effort? It's really about a completely different way of thinking, a whole new philosophy for how we build and, more importantly, how we trust our software. When you really boil it down, the C99 canon gives us 3 huge takeaways. First, discipline creates determinism. All those strict rules, they're not there to be annoying. They're what makes the software's behavior perfectly predictable. Second, verifiability is not an afterthought. You have to build trust into the very foundation of the system. You can't just slap it on at the end. And maybe the biggest idea of all, software can prove its work. It's actually possible to build systems that produce their own perfect, unfakeable audit trails. And that leaves us with one final, pretty mind-bending question to think about. I mean, this is an incredible level of discipline for one project. But just imagine, what if this wasn't the exception? What if this was the rule? What if the software that runs our banks, our power grids, our entire digital world, what if it was all required not just to function, but to prove its own work with this kind of non-negotiable testimony? What would that world even look like?
You know, in software, the mantra is always move fast and break things. But what if there was a totally different way? A way that's, well, it's almost fanatical in its discipline. Today, we're diving into a project called C99 Canon. And trust me, this isn't about speed. It's about building something with absolute, unshakable certainty. And the philosophy behind it is just fascinating. This quote right here from the project's own docs, it says it all. No stubs, no later, no platform fairy dust. So what does that actually mean? Well, imagine you're building a house, right? But you're not allowed to say, oh, I'll finish that staircase later. Or, use a temporary support beam. Nope. Every single piece, from the foundation to the last nail, has to be the final, perfect version before you can even think about moving on. That's the level of completeness we're talking about here. Everything is explicit, everything is finished, and it is absolutely non-negotiable from day one. So what is this thing, really? At its heart, C99 Canon is what its creators call a bedrock engine. And its entire purpose in life is to fight the chaos that we've all felt with software. You know that feeling when a program just gives up for no reason? This engine is designed from the ground up to prevent that. It makes programs that are deterministic, which is a fancy way of saying if you give it the same input, you will get the exact same output every single time. No exceptions. The whole point is to build software you can actually, truly trust.
Okay, so let's really get into what makes this Bedrock engine tick. What's the fundamental problem that it was built to just completely obliterate?
This slide just lays it out perfectly, doesn't it? On the left, you've got the problem we all know and hate. Software that fails silently, or, my personal favorite, works on your machine but magically breaks on someone else's. And on the right, you have C99 Canon's pretty radical solution. Instead of just guessing what went wrong, the engine creates a perfect, unchangeable record of everything it does, a testimony. The rule is simple and it's powerful. No lies, only logs. If the program ran, the proof of exactly what it did is right there. So, how in the world do you build something this reliable? Well, it all starts with a set of rules that you just cannot break. The project calls this its foundation, the core law, and it's made up of 7 incredibly strict pillars. And these are the pillars of that discipline. Just look at portability. It restricts itself to ancient standards and, get this, no threads. Why? Because threads are a huge source of unpredictability. Or check out strictness. Compiling with -where means that even the tiniest warning from the compiler stops the entire build. It's a zero-tolerance policy for anything less than perfect code. And then completeness. No to-dos, no dead code. If it's in the project, it's done and it works. These are not just suggestions. They are unbreakable laws. All right, so you've got these incredibly strict laws, but how do you even talk to a piece of software like this? You can't just knock anywhere. There is only one way in, and it's called the front door contract. There is exactly one way to interact with this engine, a single command called FIDOR. Now, most software gives you tons of ways in, right? But this is a bottleneck on purpose. And that's not a bud. It is its most important feature. By forcing absolutely everything through this one tiny door, the system maintains total control over its own perfect, predictable little world. But you can't just walk through this door. First, you need the key. The engine demands what it calls a locksmith signature. Before it'll do a single thing, the engine actually inspects its own source code and asks this really profound question: am I who I'm supposed to be? If even one character of its own code has been changed, the door stays locked, period. And this is how it does that check. Think of this as a list of fingerprints. The project has a manifest file, and for every single source file, there's a unique cryptographic fingerprint, a SHA-256 hash. Before that FIDOR will even think about opening, it runs through this list and checks that the fingerprint of every file on the disk perfectly matches the manifest. If there are extra files or if a single file is off by even a byte, the check fails. It demands perfect integrity. And once you're through the door, the procedure is just as rigid. It's always these 4 steps, always in this order. 1. Verify the entire codebase. 2. Acquire a lock, making sure it's the only thing running. 3. Execute one single predictable step of work, what it calls a tick. And 4. Commit the testimony, writing that permanent, unchangeable record of what it just did. Which brings us to the final, and maybe the most powerful piece of this entire puzzle, the output. How does the engine create a record so perfect that you can call it a non-negotiable witness? The philosophy is ledger first. This means writing the log isn't just something the program does at the end. Writing the log is the main event, and the system is fail-closed. Now, think about that for a second. Most systems, if they fail, they try to limp along. This thing does the exact opposite. If there is any error, even a tiny one, while it's writing its log, the whole system just stops, dead. It would rather fail completely than produce a record that isn't absolutely perfect. And here's how that actually plays out. On the left, you've got the canonical witness. Think of this like the master bank ledger. It is the one and only source of truth. It's unchangeable. On the right, you have derived caches. These are just helpful summaries, but you could literally delete them all and recreate them perfectly from that master ledger. But here's the crazy part. Even if there's a failure writing one of these summaries, it's still considered a fatal error that halts the whole system. And this is the ultimate result of that whole design. You don't have competing databases. There's no chance for data to get out of sync. There is only one ledger, and therefore, there is only one truth. And here it is, the final lock that makes this entire system completely bulletproof. Every single record is stamped with something called a layout hash. It's a fingerprint not just of the data, but of the entire system's state at that exact moment in time. This is what makes the testimony truly non-negotiable. It means that years from now, you can take these logs and perfectly recreate the exact conditions of the original run, proving with mathematical certainty exactly what happened.
So what we're looking at with C99 Canon is a pretty radical trade-off. It sacrifices the modern gods of speed and convenience on the altar of something that's become incredibly rare, absolute certainty. It gives us a cryptographically proven record of truth in a digital world that's just filled with ambiguity. And that leaves us with a pretty big question to think about. As the software that runs our world gets more and more complex, is this kind of fanatical, almost militant simplicity the only real safeguard we have left?
I want to show you a software project that is just a complete masterclass in discipline. It's known by a few names, but we'll call it C99 Canon. And honestly, it's built on a foundation of rules so strict, they feel like they're from a totally different era. But as you're about to see, this kind of, well, ancient approach might just be the perfect answer for some of today's most complex problems. You know, the ones where failure just isn't an option.
This single line, right from the project's own documentation, it tells you everything. It's the whole soul of the project. It's basically a declaration of war on shortcuts. No temporary fixes, no "we'll get to it later," and absolutely no platform fairy dust. You know what that is. It's that magical, platform-specific stuff that works great one day and then completely breaks the next. This philosophy shapes every single thing about this system.
So, what is this thing exactly? Well, it's definitely not an app you're going to download for your phone. It's something way, way more fundamental. The creators call it a bedrock engine. Okay, that sounds like a mouthful, right? Let's unpack it. Deterministic just means that if you do the same thing, you get the exact same result. Every single time. No surprises. And fail closed witnessing. Think of it like this. If the system can't write down a perfect note of what it just did, it just stops. It literally shuts down. It's a foundation for software that absolutely cannot fail silently, which is so critical for things like financial systems or major industrial controls. And this is where you really see that commitment in action. I mean, it's written in C99. That's a version of the C language from 1999. It's designed to run on operating systems from the early 2000s, like Windows XP. Now, why on earth would you do that? It's simple, to guarantee with absolute certainty that it will run the exact same way everywhere, every time. The whole system is just one file, governed by what they call the one canonical liturgy, a single, sacred set of rules. And that liturgy they talk about? It's not just some cool-sounding phrase. It's actually a super concrete set of 7 principles. They call it the core law. So let's take a look at these 7 pillars that build this whole foundation of trust.
And these pillars, they're basically the project's constitution. I mean, just look at number 4. All compiler warnings are treated as errors. For anyone who codes, you know that's wild. Warnings are usually just suggestions. Here, nope, they're a hard stop. Or how about number 6? No to-dos. The code isn't just working, it's declared finished. This forces you to solve problems right now, not kick the can down the road. You just don't see this level of discipline very often. Okay, so it's great to have a constitution, right? But rules are only as good as their enforcement. So how do they make sure everyone follows the law? Well, they have this really clever concept called the front door contract.
And here's the kicker. You can't just run any old part of this system whenever you feel like it. No way. Every single important action has to go through one command, FIDOR. They call it the bottleneck on purpose, which is such a great phrase. It's like, there are no secret back doors, no open windows. You have to go through the front door where the security guard is watching. And get this. Look at what happens when you knock on that front door. Before it even thinks about running, the system checks its own source code. It literally verifies itself to make sure nobody's messed with it. Then it locks everything down so nothing else can interfere. And only then does it do its job and write down a permanent record, a testimony of exactly what it did. We're talking total end-to-end integrity. This whole self-checkout process has a name, of course, the locksmith's signature. It all relies on this special manifest file that acts like a blueprint, making sure every single character in the code is exactly where it's supposed to be before the engine is even allowed to start.
So here's what that manifest file actually looks like. You can see each file has this long string of characters next to it. That's a cryptographic hash, basically a unique digital fingerprint. And it's super sensitive. If you change even a single comma in one of those files, that fingerprint changes completely, the check fails, and the whole thing just refuses to run. It's that strict.
Okay, so once a computation passes all those checks and finally runs, the system writes its testimony. And this gets us to one of the most fascinating parts of the whole project, its philosophy on what truth actually is.
The rule is no lies, only logs. I absolutely love that line. For this system, the log of what happened isn't just a record. It is the absolute truth. Whatever the current state of the system might be, that's secondary. The only thing that truly matters is that perfect, unchangeable history of everything that's ever happened, something you can replay at any time. And that brings us back to that fail-close idea. So when is a task officially done? Not when the computation is finished, but when the log file about it is successfully written to the disk. So if the disk is full or if there's some kind of random error, if anything prevents that log from being written perfectly, the whole system just stops, grinds to a halt. Because again, it's way safer to just stop than to keep going when you're not 100% sure what's going on.
This really shows you how it works in practice. On the left, you've got the canonical witness. That's the JSON log file. That's the master record, the primary source of truth. Everything else, like the files on the right, are just derived caches. Think of them as convenient copies. They're totally disposable because you can always rebuild them just by rereading the main log. But a failure to write to that main log, oh, that's a 5-alarm fire, and the system treats it that way.
So let's just wrap this all up. What we have with C99 Canon is a bedrock engine for building software you can count on. It's all built on a strict core law enforced through that one single entry point, the PHY door. And its most fundamental belief is that the log file, the witness, is the one and only truth, and it will literally shut itself down before it ever lets that truth be compromised. Which really leaves us with a pretty big question, doesn't it? You know, we live in this world of software that's just getting more and more complex every day. Constant updates, tangled dependencies, systems so complicated that nobody fully understands them anymore. So is this the answer? Is this radical, almost fanatical simplicity the ultimate safeguard? Is this how we build software we can actually truly trust? It's definitely something to think about.